will be convolutional layers along with activation function layer, and in between there will be pooling layer. So this will be repetitive because how many you can add n number of convolutional layers, and I'll explain the methodology here. So you can see this is a convolutional kernel. You all know that the images are arrays only. Okay, so it is a kind of matrix. So the pixels will be arranged in this manner. So you can see a kernel sliding over the image. Okay, so this kernel learns the features. So this filter, this kernel will be defined by us. That is the size of this kernel. Okay, this kernel will extract features based on this size. Okay, so this I'll show in the code also. You can see this diagram. You can clearly see that in this first image pixels, that if we choose 3x3 kernel, okay, you can see there are 3 rows and 3 columns. So this is 3x3 kernels. So here the 3x3 filters will be generated automatically. Okay, then element wise multiplication will be done. You can see the first element in the first matrix, that is 0 into 4. Likewise 0 into 0, this element wise multiplication will be done, and finally the value will be placed. So these all elements will be added, that is -8. So this will be placed here. So likewise the slide, for every sliding there will be a calculation like this. So this is how the CNN extracts features from the source images. Okay. So here padding is another method. So padding is nothing but we are not going to miss any corners in the image. We are going to add zeros in the top, bottom, okay, side, that is left and right of the image, because the corners of the images will not be lost. Okay. So if you have any importance in the corners of the image, you can use this padding, otherwise it is not needed. So in most of the problem for image classification problems, we will be using ReLU activation function. So what is an activation function? So activation function, it will be deciding whether a neuron is to be fired or not, whether that neuron produces any meaningful output or not. So in case of convolutional neural networks, we will be using ReLU, rectified linear unit activation function, because as you see in this graph, so the equation is f of x is equal to max of 0, x. So here only positive values. Suppose the value of the pixel is 1, the corresponding pixel will be 1. Okay. So suppose if the value of the pixel is 9, then the value of the corresponding function will be 9. Okay. Suppose if you get any negative values, all the negative values are zeroed out, because while generating filters automatically, so we'll have some minus, that is negative values also. When multiplying this with the image, you will be getting some negative values. So these negative values are eliminated using this ReLU. So pooling layer, this is a dimensionality reduction layer. So you can see a 4x4 filter here. So after applying pooling, okay, pooling with 2x2 filters, you will get 2x2 matrix. Okay, so we are reducing the dimensionality here. So detailed explanation. So here how the pooling is done. If we define pooling as 2x2 stride, then what it will happen is, first it will take 2x2 stride. Then among this, which is the, suppose we are using, if we use max pooling, there are 3 types of pooling here: max pooling, min pooling, and average pooling. So most of the time we will be using max pooling. So in case of max pooling, among these 4 elements, the maximum value is 20. So that is placed here. Likewise, the stride moves here. So you can see here 30, 0, 2, 0. So which is the maximum one here? 30. So that will be placed here. Likewise, this stride will be moving on. Then we will be getting the final dimensionality reducted feature. Okay. If in case of average pooling, it will add these 4 elements and divide by 4. Okay. That's just we are taking the average of these 4 elements, 4 pixels. So we are using this only for reducing the dimensionality and to extract very complex and important features from the input image. So there are n number of data sets for image classification. So for handwritten classification, there is a popular data set called MNIST. So it has training set of 60,000 and test set of 10,000. If you are doing any projects, you can directly use this data set for image classification. So this is LeNet is an architecture, that is a convolutional neural network architecture that is especially designed for handwritten image classification. So Cipher 10 dataset, it is also a popular dataset. So this dataset contains color images, whereas MNIST contains only black and white images, that is grayscale images. So ImageNet, it is a huge database. It consists of millions of datasets. So these are some of the convolutional neural network architectures, that is popular architectures that were designed already: LeNet, AlexNet, GoogleNet, VGGNet, ResNet, etc. So can you see my screen?
Yes, ma'am.
Okay. So for Python, for executing Python programs, that is most importantly deep learning programs, we need a GPU, that is graphical processing unit. So we can, Google is providing a free platform for executing these things. So that is Google Collaboratory. You can go to the Google search, and if you type Google Collaboratory, you can see this link, and you can, if you click this link, you will get a notebook like this. You can go to the file and you can create new notebook, and the notebook will be open like this. So for this purpose, today I am going to give you a hands-on on brain tumor classification. So we are going to classify whether the slices have tumor or not. So initially what we have to do is we have to save our data, that is upload our data to our Google Drive. So in Google Drive, you can create a new folder. So I have created inside this collab notebooks, okay, training and testing. So inside training, you can create subfolders, that is tumor, no tumor, and you can place the tumor images here, then no tumor images here. Likewise, in the testing folder, you can create the same tumor and no tumor. Okay, this is my drive. I have saved all my files here. So it is necessary that you should use 80% of your images, that is training data, in training, that is for training, and for 20% for testing. So you should divide like this. Then you should not use the same data that is used for training. For the testing data must. So you should partition this like this. Then we are going to use the, we are going to change the runtime in the Collaboratory. So here in runtime tab, go to change runtime type. Then here you can see GPU, TPU, none. If you give none, it will give you some CPU cores. So select GPU and you save. After that, you can connect. If you click on this, it will be connected. So first of all, we have to import drive. We have to mount the drive to this Collaboratory notebook. So this is the code for that. From google.collab, import drive, then drive.mount content drive. So this is the code for mounting our Google Drive. So run this cell. So here you will get a dialog box like this. Permit this notebook to access your Google Drive files. Then you should give connect to Google Drive. So my Gmail account is this one. So I am connecting to that. Give allow. So here you will get a output as mounted at content drive. Okay. So next, for next code, you can click this code, then you will get a code cell like this. You can paste, you can write your coding here. So we have to mount each and every folder that you need for your program. Okay, so this is the code for mounting our folder. So this is the path where I saved my training data. So you can also navigate to that path. Okay, so content, inside content, drive, my drive, collab notebooks. I have this training data. Then finally tumor images. So I run this one. So I'll get the images that are saved in that particular folder. Likewise, I am mounting this another folder, that is no tumor, the same path, but here no tumor. Then no tumor images are loaded. Again, in testing, I am going to mount the tumor folder. Okay. Then for testing, no tumor folder. So whatever, whether you are writing to the folder or you are reading from the folder, you have to use this coding for mounting. Otherwise, you will be getting some errors. So now we can move to the main program. So in case of Python, you should import the particular libraries that we need in our programs. So here I am importing some required libraries such as pandas, numpy, matplotlib, keras. Okay. So here pandas are used for data manipulation and analysis, whereas numpy is used for arrays because we are going to use images as inputs and we are going to pass the images as vectors. So we are using this numpy. Then matplotlib for plotting something, plotting the images or plotting the graphs like that. Then we are importing the model type, that is sequential. We are going to use sequential model because we are going to use linear stack of layers. Okay, layer by layer we are going to execute. So we are choosing this sequential. Then we are importing convolutional 2D because we are going to use the convolution neural networks. No, we have to do this convolution operation that I shown in the PPT. Then after convolution, we are going to use max pooling. Okay, there are 3 types of pooling. Among that, we are going to import max pooling for our problem. Then finally, dense. There will be fully connected layers at the end of the CNN. You all know that. So we are going to use this dense. Dense means there is fully connected layer. And finally, flatten. Flatten means so the images will be flattened. That is, it will be in the form of vectors. So we are going to fit the CNN to the images here. So this is the importing statement. From keras.preprocessing.image, import image data generator. Because in case of deep learning, we should use huge amount of data. So in case of medical images, there are only few images available. So we are using some pre-processing techniques for generating images from that original images. Okay, we are sharing, zooming, we are doing some horizontal flip, we are rescaling it. Okay, we are producing more data, we are generating more data from the original one using this coding. Okay, train data gen, this is the name that we defined. So this is the syntax for generating image data generator. And here, what are the operations? There are more operations here. We can do vertical flip also and everything, but I have used these 4 things only. So we are providing some range also. After that, we are generating data for testing set. Okay, test data gen is equal to image data generator rescale. We are not doing any flipping operations here. We are just going to rescale the image for testing purpose. So now we are creating the training set. We have to train the data to the CNN. So we are creating the training set here. You can see the coding. So this is the user defined name. You can keep any other name also. This is the user defined name. So this is the coding. Train datagen dot flow from directory. So you all know that we have mounted before. Okay. So I need the training data. So I use this training data path. I mentioned the path here. Then the images are reshaped to 64 cross 64. Then batch size is 32. So what is meant by batch sizes? So the input images in our example that I used today is 895 training samples. Okay, so it is not possible to send all these images at a time. So we are sending the images, that is we are training the images batch by batch to the CNN model. Okay. So here we are going to classify whether the image contains tumor or no tumor. So we are using the class mode as binary. If you use more than 2 classes, you can use categorical. Okay. So I am going to use only binary classification problem. I am using this binary class mode. Then now we are creating the test data set. Test set the same as training data set, but here the path to the test set is given. Same thing, we are rescaling, that is reshaping the images, then batch size are given, then class mode is binary is given. Okay, if I run this, so before compiling this, I moved to that part, so I got an error. Okay, so here I have defined the image data generator. I have not compiled this, so I got error. Now this part is executed. So it listed the images. Okay, 895 images were belonging to 2 classes from training set, then 173 images to that are belonging to 2 classes from testing set. Okay, then I'm defining some variables here, that is how many number of training samples, testing samples, then batch size and approaches. Okay, this is the architecture of CNN. Okay, as I shown in the PPT, so we are going to use linear stack of layers. So classifier is equal to sequential. So we are going to create a classifier, isn't it? So we are going to classify whether the image input contains tumor, input image contains tumor or no tumor. Okay, so initially what we are doing is classifier is equal to sequential. We are specifying the type of classifier. Then in the first layer, classifier dot add convolutional 2D. Okay, 32, 3 cross 3. So here 32 is number of filters. Okay, number of 3 cross 3 filters. So from the first layer, there will be 32 filters with 3 cross 3 kernels. Okay, the input shape is 64 cross 64. Then activation function uses relu. I already explained why we used relu, because it will zero out the negative part. Then after this convolutional layer, we are going to add max pooling. Okay, so max pooling, you all know that operation also. I have explained that. So we are using that same 2 cross 2 stripe here. Finally, we are flattening. Okay, before going to the fully connected layer, because you all know that in fully connected layer, the image will be in the form of vector. Okay, so the dense layer, we are specifying how many number of neurons should be there, that is 128. And here the activation in first fully connected layer, we are using relu, and in the second fully connected layer, we are giving 1 here, because we are going to tell whether the input image contains tumor or not. Okay, so only one output will be found. Okay, we are using the sigmoid activation function because sigmoid will return whether 0 or 1, only 0 or 1 will be returned. Okay, if the images contains tumor, means it will return 1, otherwise it will return 0. This is used for binary classification problem. In case of categorical classification, you have to go for softmax, because softmax is based on probability. Okay, from 0 to 1, there will be some probabilities. Okay, if suppose there are 4 classes for our classification, then 4 probability will be generated, and the class with higher probability will be given as output for us. Okay, so in case of binary classification problem, we are using sigmoid. So I am printing the summary of this model. So you can see in convolutional layers, the output shape will be like this. Then parameters. Okay, you can see the number of parameters here, and total parameters, trainable parameters, and non-trainable parameters here. And finally, for training, we have to fit the model to the image generator. That is, we have to fit the model to the training set. Okay, so here before fitting, we are compiling this. So classifier.compile So we have to provide the optimizer, because optimizer is essential for back propagation. Okay, we are back propagating the errors. Okay, the loss function. So before back propagating, we should use some loss function, no, for calculating the errors. So we are using binary cross entropy here. In case of multi-classification problems, you can use categorical cross entropy. Okay, then I'm going to calculate only the accuracy. So matrix is equal to accuracy. So how accurately the testing set that is given. Okay, the results are produced. So finally, we are fitting the model to the training set. So here we are giving the steps per approach. So what is meant by an approach? Okay, approaches is the number of times the learning algorithm sees complete data set. So iteration is different from approach, because one forward pass and one backward pass is known as iteration, whereas so this is iteration will be calculated for one batch. So if one batch is moved for forward and backward pass, it is known as iteration, whereas approaches all so how many the number of iterations that all data, that is all the batches are processed, that is known as one approach. Okay, so in one approach, the number of times the learning algorithm sees complete data set. Okay, so we are training the whole data set for how many approaches? Okay, we can train the data set for n number of approaches. Okay, if we increase the number of approaches to an acceptable level, you will get a good accuracy, that the model will be trained very well. Okay, so the approaches should not cross the limit also, because if we train the model too much, then it will get some confusion. Okay, so overfitting will occur. So in case of deciding approaches, we should be very careful. So for fitting here, I have given the number of approaches as 1 for time consumption. Okay, you can give n number of approaches. I am training the model for only one approach here. So you can see this arrow mark, this will be increasing because this is one batch. Okay, so one batch contains 32 images as I given here. Okay, batch size is 32. So this is one iteration, one forward and one backward pass. Okay, now 4 iterations are completed. Like there are 27 iterations for one approach here. So the data set, the model sees the training whole data set for one time. So the more number of input images you give to the CNN, it will provide more accurate results. The data set is small, then the accuracy will be somewhat lesser only. So in case of moving to deep learning models, we have to concentrate more on data, using data sets, huge data sets. So another drawback is if we use CPU, then we have to wait for days to compile to train a model. So it is better to use Google Collaboratory. So they are providing 12 hours for per day, 12 hours free for 1 day. So here the model is trained. Now we have to evaluate the model. Okay. So classifier dot evaluate generator. Okay, we are going to evaluate the model using our test set. Okay. So test set that is not seen during training. Okay, the model doesn't know the images in the test set. It is going to predict the images, that is images that will be in the test set. Okay, finally we are printing the accuracy here. Okay, so the accuracy is 80%. So this is not fair to run the model for one approach because it is taking too much of time. I have trained this model for one approach. Okay, you can use 50 or 100. Okay, that is up to you. You can find which is the optimal number of approaches that you can use for your training program. So 80% with 80% accuracy, this model can predict whether the prediction images contains tumor or not. Okay, so that's it. If you have any doubts, you can ask me.
Ma'am, Jayanti Deepan has asked one question: how to collect medical data?
Okay. So for getting medical data, you should go with your institution. You should go via your institution only. So for brain tumor data set, there is a publicly available data set, that is BRADS. So most of the popular research is going on with that data only. You have to for every year they will be providing data to us. So you can move with your institution. Okay, they will ask for your institution mail ID for collecting that data. So then you can have some unofficial data sets from kaggle.com, like that. There will be some data available for medical images. So Saranya ma'am, so you have asked how to find the optimal number of approaches. So that is separate research area. You have to read more number of papers. So it depends on the domain, and it depends on the model architecture and everything. Mostly you should find that using by performing several experiments you can find for your particular application. So it differs from application to application. Any other questions, ma'am?
So I think my screen is visible, right? So basically, I have taken a multi-class classification of plant leaf disease detection. Okay, so it comes from deep learning. So deep learning is a type of machine learning and artificial intelligence that imitates the way that a human certain types of knowledge. So DL is a technique that teaches the computer and what comes naturally do humans and learn by examples. Okay, so the deep learning is a computer model learns to perform a classification task directly from an image or sound or some task. Okay, so that is we have to train a model by using a large set of labeled data. That is a supervised learning. So yesterday ma'am taught supervised and unsupervised. So here we have used a supervised learning. Okay, so here we use neural network architecture. So it comes basically deep learning. Okay, so some examples of deep learning is automata driving, aerospace, defense, and medical research, and industrial automation, and agriculture, and so forth. So nowadays, artificial intelligence is a main focus we are using in all of the areas. So if you take on hospitals, so they are using artificial intelligence to operate the human, right? So how deep learning works? Already before that, Priya ma'am told, right? So these are the things we have to implement in deep learning and find the classification of the what this is that presently affected in that leap. Okay, so how deep learning works means, so most of the deep learning model we use neural network architecture. Neural network architecture is nothing but it is based on human neurons. Okay, so it basically works our human brain. Okay, so the term deep usually refers as a usually refers to a number of hidden layers that is present in a neural network. So traditional neural network contains only 2 or 3 hidden layers, but we are using a deep neural network, right? So it has some more than 150 hidden layers we have used. It is basically dependent on our database. I mean the data set. If you use 50,000 or 20,000 data set means we have to go to n number of hidden layers. So hidden layers is well suited for our problem. So that is basically choose it is suitable for our problem or not. So hidden layer chosen is only the one of the important part we have used in neural network. So deep learning models are trained by using a large set of labeled data, and neural network learn features directly from the data without the need of manual feature extraction. Okay, so if we have to taken feature means is nothing. If you take a cat image, so cat has eyes, nose, and these are the things, right? So these are the eyes and nose and ears. These are the features. Okay, so what deep learning done means, so these features are manually not extracted by the human. So deep learning learns the features by its own self. Okay, so this is the main thing we have to use in deep learning. So one of the most popular types of deep learning is the convolutional neural network. As ma'am told, right, convolutional neural network. So it learns features with input data and uses the 2D convolution layer. 2D convolution layer is nothing but it is a two-dimensional. Okay. So we are using maximum we are using in the images. Okay. So on see why we have used CNN means, so CNN eliminates the manual feature extraction, and CNN works extracting the features directly from the images. So this is the main thing we are using the CNN, that is a convolution neural network. So convolution neural networks, if we take the following layers, that is convolution ReLU layer, that is the activation function, and polling layer and fully connected layer. So these are the important thing we have to use in the convolution layer. So in one layer, it will present a convolution layer. Padding is already that ma'am told, right? So input shape we have to already here. So height and width and depth of the image. Okay. So activation function, batch normalization. So max pooling. Here we are using a max pooling and dropout. Okay. So first I have to show my. Okay. So the process of CNN, that is a convolution layer means, if you give one image means, so line up the filter and then image and multiply each image with the pixel with the corresponding filter pixel. Okay, so if we give the pixel right, filter pixel right, so it will be multiply each image pixel by the corresponding filter pixel and add them up and divide the total number of the pixels in the filter. So here I will take a data set And this is example. Example is nothing but this is testing data. Okay, so testing data and data set. So here I will take 13 types of diseases. So apple, corn, early bright. So this is a tomato and peach. Okay, so these are the data types I have to take chosen. So there are 13 types of data set. And here one folder, that is a smaller VGGNet. Smaller VGGNet is nothing. I have created a convolution neural network. So I will explain now. So this is the format. So data set, examples, and one folder, training and classify. So training is training means what are the things we have to train, and classify means the testing part. Okay, and this is the command we have to train and testing the data set. Okay, so first I will explain the code. So how to create a model means, so this is the way how to create a model. Now I have to teach is the offline. Okay, so offline means how to install the Anaconda from. So Anaconda is the offline editor which is used to based on your system RAM room. Okay, so Padma ma'am told is the online, so I will do the offline procedure. Okay, so if you install the Anaconda prompt, and you can easily access from anywhere without using the internet. Okay, so here I will import the library files. So model, how to create a model is a sequential. Sequential is nothing but it's a one and by one, right? So sequential, batch normalization, convolution 2D, max pooling, activation function, flatten, a dropout, drains. Okay, so here I will build a one class. Okay, so here I will create a model called the sequential and input shape and channel dimension. So here I have to build a model. Okay, so model that add convolution 2D and filter. So this is the filter size. Okay, so 3x3 is the kernel size. Okay, so this is the way I have to use a create one CNN layer. So dropout, why I have to use a dropout means if I have to take 13 types of data set, right? So it contains maximum 5,000 images. So if the images will be increasing more than n number of images means, so the system will be mugging, right? So mug up their features, right? So that only I have to give a dropout. So the main use of dropout means it makes some neurons to relax in that particular layer. Okay, so this is the main thing. So it will be some neurons to be relaxed in that particular layer. Otherwise, it will be situated on the next layer. Okay, so this is the main. Why we use dropout means we have to avoid the overfitting. Okay, so avoid the overfitting, we have to use the dropout. So dropout is basically based on your own. So if you if here I will reduce 25% of dropout. Okay, so if the database means 50,000, so I will list 25,000 of features to relax. Okay, so this is the one CNN layer to create. Okay, so here I will use a max pooling. So here one convolution layer, two convolution layer, 3, 4, 5. Okay, so 5 convolution layer. 1, 2, 3. Okay, 6 convolution layer I have created. So same I have used, and finally dense layer. So and flatten is already told, right? So it will be convert a single vector, so multi-dimensional vector, and it will be convert a single vector. So that only we have to convert easily classify the data, right? So this is the one example of creating a model. Okay, and if we say one name, and it will be import in the training phase. So this is the next one. So I have created 3 types of files. Okay, one is for model, another one is for training set, and another one is for testing set. Clearly? Okay. Okay. So next one is training. So training is nothing but here we have to train the data set based on our system. Okay, so it will be some system will be accepted the easy computation time, but our system will be take much more time. So that only I have already run, and I only tested the data set. Okay, so here import the necessary packages. So you can ask me how to import this file, right? So here I will import. from KRSM VGGNet. So here I will import the file, right? So here this file will be present in KRSM. So SM smaller VGG net. Okay. So can you understand? So these are the image data generator. Image data generator is nothing. It is accepts the input batch of images and randomly transfers the images. Okay. So Adam is the optimizer, and this is I will create a for JSON, that is a mobile app or web app. Okay, so that only I have to given a JSON file. If you don't need, you have to put a command line. Okay, so this is nothing important. Okay, and this is converting image to array and multi-label classifier. Why we have multi-label classifier means I have used 13 types of data set, right? And here I will to split the train and testing data set, and these are the matplotlib and classification report. Okay, so these are the library files which I have used, and so this is the way. Okay, so how to fetch the data set and how to create a model and how to create a label bin, and this is the plotting. So I told, right, so this is the command for training the code. So Python train.py. So this is the data set. Data set will be fetched from our system, and the model. So the model will be trained and it will be saved in our system. So that only model leaf.model. So this name will be once our model is trained. So this model will be stored in our system, and label bin dot. This is a pickle file. Okay. So this one I have to given the argument pass the arguments. So this is the way I have to given. And this is in epochs. Epochs means run the patterns by incrementing improvements by way of the back propagation. So here I will given a 5 epochs. So it takes too much of time. So I will give sample 5 epochs. So this is a linear learning rate. So initially learning rate for Adam optimizer is LE minus 3, and batch size basically depends on your problem. Okay, so here I will given 64, and grab the image part and randomly shuffle them. So I have to get the images. So here, yeah, so here I will run the program. So Python train.py dataset -dataset model leaf.model label bin mlp.pickle. So this is the name of the file. Okay, so using TensorFlow it will run. Okay, so here it will be loading the images, right, and the data matrix. So this, yeah, I have taken 4,862 images, and this is the space of the images, right? Okay, so these are the way how to given this part. Okay, and here we have to partitioning the training and testing data. So here I have to split in 70% of data set into a training set, and 30% of data into a testing data set. Okay, so here we are using a image generator for data augmentation. So in that they will shuffle the data to augment the data. Okay, so here rotation and width shift ranging, height shift ranging, shear ranging, zoom ranging, and horizontal flipping. So these are the data augmentation that will be done in the entire data set. Okay, so here only we have to initialize the model. So why we are using softmax means I have used more than 2 classes, right? So fine. So that only I have used softmax function. So I have to build smaller vgg.build and width, height, and width. So classes, here I will define the classes of the data set, right? So this is the initialization of the optimizer. So which optimizer is suitable for your problem you have to taken. So there are a lot of optimizers are done. Okay, so here only we have to compile the model. So model.compile loss equal to binary cross entropy. So optimizer already we have to define, right, and metric. So here you have to train the model. So I will given one name and model.fit.generator. So these are the thing we have already given in above session, right? And this is the way we have to save the model under this. So already I told, right? So how we have to create a website. I mean, website means you need the JSON file, right? So that only I will given a JSON file. If you don't need means, so you have to command these 3 lines. Okay. Sorry, these 2 lines. Okay. And here you have to save the multi-label binalyzer to disk. So this is used for plotting the training and training loss, validation loss, accuracy, and validation accuracy. So if I run this program, I will get this output. So class label. So these are the class label which is present in that dataset folder, right? So it will be taken. So it takes much more time. Okay, nearly based on your system, it will be taken time. And I will run this. Yeah. So this is the layer output shape. So convolution 1, 2, 3, 4, 5. So 6. So 6 convolution layer are used. Okay. So and finally, I have used total parameters is 3,83,661 and with non-trainable parameters. Non-trainable parameters means, so these are the parameters the model will not trained. Okay. So here I will give one, first I will try the 2 epochs. Okay. So 2 epochs means, so the accuracy is 0.7183 and the validation accuracy is 91. So that is some mismatch, right? So again, I will train with 5 layers. So I will got, okay. So again, I will try with the 5 layers. So it is basically depend on your own problem, okay. So it will be take some minutes. So accuracy is 92.74 and the validation accuracy is 97.56, right? So it's for 1 epoch and finally it comes of 5 epochs. So 96.05 and the validation accuracy is 94.86. Okay. So first we have to train the model means first we have to import the library files and what are the arguments we need, that one, and initialize the epochs. Okay, epochs linear and batch size, and grabbing the image data set. So we have to get the image into an array. Okay, so these are the way, and then finally we have to partitioning the data for training and testing. Okay, so which is suitable for your problem. If the data set is very low, means you have to divide 80 and 20. Okay, so here I will take a more than n number of data sets, right? 4,800. So that only I have to divide the data set as 70 and 30. Okay. So image data data generator, so which is used for data augmentation. Okay, and finally you have to initialize the model. Okay, and optimizer. So optimizer is which is used and compile this both in to fit the model. Okay, so training and save the model and have to plot. Okay, so here I will explain. Okay, so leaf.model. So just now I ran it. So today's date it will say leaf.model, mlp.pickle and model.json. Okay, so plot. So I will run only 5 epochs, right? 1 minute. Yeah, I will run only for 5 epochs. So it will be if you run more than 50 epochs, so that was reach a highest prediction. Okay, if you so here there is some n number of mismatch, right? So if you run 50 epochs means, so the accuracy will be, sorry, the classification will be displayed accurately. Okay. So and this is for testing. Okay. So before that we have to create one model. So CNN model, and that model will be implemented in the training phase, and finally we have to go to the testing code. Okay. So once a model is trained, so in general deep learning take you that is getting a model, train a model and validate the model. So these are the phases are important, right? So once our model is trained, we have to check the model is correct or not, right? So these are the files. Okay, so here we will load the model. Why we load the model means, so already our model will be saved, right? So just we have to load the model for the testing phase. Okay, and this is the image. So image is nothing. This is a testing image. It will be if you take on a live image, that is a form images. Okay, so that when we, if you take form images means, so you have to analyze how our data will be model will be trained. Okay, so if I give only 5 epochs means, if I give 5 epochs, right? So our data will be trained at not good. Okay, it will be trained, but it will be not trained at not good, right? So if you go for with 50 or 75 epochs, it's based on your problem. Okay, and load the image and pre-process the image of classification, and it will be getting to take a model and classify the image. So here it will be calculating the probability. So these are the classification to probability of finding the accuracy of the diseases. So if I give one okay. So this is for 2 epochs, right? So if I give 2 epochs, so the model will be this one will be go to the our system, and it will be go to the model. So it will be checked to the model. So the model will be loaded in a, okay. So it will be display healthy, okay. So the leaf is healthy leaf. So there is no any diseases are present in this leaf, right? So this is a healthy leaf, okay, and this is a corn leaf, okay. You already know corn leaf, right? So this is a corn leaf, and this is the healthy is 89.52. So these are the these are the. So here it will be show how it how many percentage it will be affect the diseases. So bacteria apple blocker 0.0. So it will be run much more. I mean it will be trained well good. Okay. So if I give another one, so it will be trained. Some of the features it will be taken. Okay. So healthy 100%, right? So that is a no disease affected in that leaf, right? So healthy 100%. So otherwise it will be displayed a 0, correct? 0 0 0 0 0, and healthy will be present in. Okay. So this is a healthy, and now I will give an here unhealthy leaves. So unhealthy leaves is okay. Okay. So bacteria, black apple blocker. Okay. So I will check you the so. So this is a data set, apple backward. Okay. So how to mismatch. Okay. So apple backward. So this leaf is presented in apple blocker 99.96%. Okay. Okay. So if I give where any diseases means, so I will give you 28. Okay. So it will be check the load model. Okay. So it will be go to the load model, and it will be check the model yeah, here it will be displayed apple scab. So these are the diseases, right? So this and these. So these are the diseases affected in the leaf. So the healthy leaf. So it will be taken the not blurry place. So here there is a blurry. Okay. So it will be take this place, and this apple healthy is 8%, 0.08 percentage. Okay. So up to this, I will check one more picture. If you give more than a number of epochs, means it will be show a good accuracy. So peach bacteria spot, right? So I will show you the peach data sets. Peach bacteria spot. Okay. So it will be predicted correctly. So our model will be trained very good. Okay. So not very good. It will be some minor mistakes, right? Okay, so basically this is come from one model. We have to create out from this. So these are the model creation, and the created model will be imported in the training phase. Okay, so here we have to import the model, and these are the library files. Okay, and these are the arguments. We have to fetch the data, and these are the number of epochs. Okay, and these are the way we have to import the images and partitioning the images and image data generator. So it will be useful for data augmentation, compiling the model. Okay, so compiling the model before up to this. Okay, and here we have to create a JSON model which is used for creating a website. Okay, and this is a plotting. Okay, plotting code. So this is for only for training and for testing. So same packages, then argument passes. Okay. So here we you know the difference between training phase and testing phase, right? So here we have to dataset, model, label pin, and plot, right? So here model, label pin, image. So what are the image we have to divide? What are the image we have to? What is this? Classify. Okay, so that will be given in that place. Okay. And here it will be load the images and pre-processing the image. So once we have to train the image by using the same size, right? 96 into 96. So here we will so the testing image will be resized into 96 into 96, right? So the same phase we have to using the testing phase. So what are the phase we are using in training phase, that will be followed by a testing phase also. So if you take a photo in the farm means, so that pixel size and the image size will be much more greater or much more lesser. So it will be resized in 96 into 96, right? So here load the train convolution model, and here we will use a multi-label binaries. Okay, and classify the input images. So how to, here will be calculating the percentage. So I will explain, right? So how it will be classified means, so based on this it will be classified this percentage, right? So this percentage, how it will be classified mean, so here we have to given, right? So a number of probability. Okay, so based on this it will be calculating the percentage. Okay, so I will give you another example. Okay, so let me check another one. Okay, 23. Okay, so some of the images are not predicted well, right? So the model is not good for this way. So what we have to do means we have to train a model with 10 epochs or 20 epochs. Okay, so most of them it will be predicted correctly, and one or two images it will be not correctly clearly, right? So what we do means we have to do retrain a model with here it will be predicted con 62% for 6 by, right? And late bite is a type of a diseases. Okay, so 28.93 it will be present in that leaf. Okay, so in some time it will be not working for all leaves. Okay, so here we take on as the 4 types of images. It's already told: apple, corn, tomato, and peach. Okay, so basically these are the way we have to multi-class classification of plant leaf disease. Okay. So this is so these are the codes for classifying by using the Python. This is offline. Okay, and now I will be telling you online. So just I will explain this. So transfer learning is nothing. Already we have to train one model and we have to just implement that model in our for our data set. Okay, so already if you know what is the work, so that model will be trained. If already we trained, right? So that model will be trained with our new data set. Okay, already data set will be trained with another model. So that model will be taken into a new model. So that is a transfer learning. So just I will explain what is a what. So here using the library function. So here using inception tree. So this is a pre-trained architecture. Pre-trained architecture means already someone will be trained and uploaded into your Google. So just we have to load our model. So load our model instead of creating this, right? Instead of creating this, okay, instead of creating this, we have to fetch the model. Okay, we have to fetch the model, I mean the trained model, and we have to use in our data set. Okay, so this is the way how to creating drive. Already Padma ma'am told, right? So this is the way we have to. So this one will be running is the offline. So this is Jupyter. Okay, and this. So okay, so this is a taken for images. So healthy and unhealthy. So I will given a path. Healthy and unhealthy, so images and label, so it will be converting into a array. Okay, so this is for healthy, this is for unhealthy, this is for healthy. So label, okay, so the zeros are healthy, unhealthy, and ones are healthy. Okay, and finally, so here it will be, here only we have to pre-train, use the pre-trained model. Okay, so extend equal to number of numpy array dot images and labels. Images is nothing, so these are the labels, right? These are the labels, and these are images means already we have to take on, right? So these are the images. Okay, and normalize the data. So here only we have to download the pre-trained model and implemented in our own data set. Okay, so here include top equal to false means, so the one set of face we have to taken. Okay, so here if you run the code means it will be automatically download the pre-trained model. Okay, so just you have to add this model before the flatten. Okay, so flatten face. So here we have to create a flatten, right? So instead of these coding, we have to implement the inception model, already pre-trained model. Okay, so this is transfer learning. So here we have to, load the data set, and just we have to add the final layer, that is a sequential layer, and compile the model and train the model. So here I will give 100 epochs. Okay, so 100 epochs, and here I will be given a, so this is the start time and this is the end time of the 100 epochs. Okay, and finally the model will be saved as a inception v3.tl. Okay, hash5 file. So I will run 100 epochs. Okay, so here the data set will be less. Okay, so the time taken is 10.26 seconds. Okay, so here I will print the model summary. So already I taken pre-trained model, right? So that weight will be added here, and that weight will be included by this weight and this weight. Okay, so finally it will be adding, and the total parameters will be displayed. Okay, so total parameters, trainable parameters, non-trainable parameters. Okay, so this is a code for testing. Okay, so once a model is trained, right? So once a model is trained, a model is saved inception v3 underscore tl dot hash file. So once a model is trained well, okay, so here will import the library files and from keras that application inception v3. Okay, and here only you have to load the inception model and healthy path, unhealthy path. So path will be getting from the local system. Okay, so this is a unhealthy. So here only we have to load the images and convert the images to array, and here only we have to implement the inception v3. Okay, so feature extraction. So these functions will be used for predict the diseases. So here we have to given n number of numbers, n number of test data set, right? So that only we have to given this process, or else we have to move for this way. I mean, yeah, or else we have to move on image underscore. Okay. So print dot predict. So yeah, here we will be given as a predict, right? Predict dot append result of 0. So predict dot append result of append 1. Okay, so here so 1 and 0. So finally the prediction. So this is a test data set I have to given in our own own local system, and actually, so this is a prediction, and what it actually present in that image means, so 0 0 0. So this is a actually present in that image, and this is a prediction. Okay, so finally have to confusion matrix. So confusion matrix is nothing, true positive, false negative, true negative. So this is the way you have to calculate actually what is present in that image. So it will be correctly fine or not. So true positive, true negative. True negative means actually that this is present, but the output will be a negative. Okay, so this way we have to calculate the confusion matrix, and finally score of the model. Okay, so 98.61. So classification report. So actual prediction. So precision, recall, F1 score, support. Support is nothing. So how many data set I have to taken for testing? So 87 and 57. So it will be correct 0.98 for precision and 100 for recall. That is a true positive, true negative. Basically, that is a calculation will be done in some mathematical calculation, some formula. Okay. So here will be calculate micro average. So average is 99.99. So here 98.6, right? So 99. So total number of images for 0 and 1 means 0 is a healthy leaf and 1 is the unhealthy leaf. Okay. So this is a transfer learning by using the pre-trained network model, that is an inception network. Okay. So there is a number of pre-trained model available in net. So in reason SpeedNet and efficient net. So efficient net is up to B8. That is a 8 level of efficient net are present. Okay. So a number of pre-trained models available. So you can use it, and you have to predict your diseases. So yeah, I will end my session. If you have any doubt, you can ask me.
Is there any queries? Thank you, ma'am.
Thank you, ma'am.
Thank you for the hands-on session on multi-class classification in plant leaf disease.